A security camera mounted to a garage door on a residential street in Montpelier, Vermont, recorded something unusual in the early hours of a Tuesday morning in February. The camera had captured foxes before, raccoons, the occasional white-tailed deer picking through crusted snow. But what moved through its frame at 2:17 in the morning was none of those things. A cow moose, standing close to 6 feet at the shoulder and weighing somewhere near 900 pounds, walked down the center of the road at a slow, deliberate pace. Her long legs moved through the empty intersection like pistons working through cold air. Her wide, cupped ears rotated toward the pale yellow glow of a street lamp mounted on a wooden utility pole overhead. She stopped once, squarely in the middle of the road, and turned her heavy head toward a row of darkened houses with their porch lights off. Then she kept walking, disappeared beyond the edge of the camera frame, and was gone. The Vermont Fish and Wildlife Department received the report the following morning. It was not the first such report that winter. It was not even the fifth. The easy explanation would have been displacement, a single confused animal moving through unfamiliar terrain and finding its way back to forest by morning. Wild animals wander. They always have. The history of wildlife management in North America is partly a history of unexpected appearances, animals turning up where they shouldn't and moving on before anyone could document them properly. A moose in a Vermont town in February is unusual but not, on its own, alarming. What made these incidents worth looking at more carefully was the pattern that emerged when you stopped treating each one as isolated. The moose appearing in Vermont towns were not stumbling through disoriented. They were not injured. They were not fleeing anything. Multiple game wardens and wildlife officers, filing their incident reports independently across different counties and different winters, kept noting the same thing. These animals appeared calm. They appeared purposeful. They appeared, in some observers' language, to be exactly where they intended to be. No one has offered a fully satisfying explanation for why. Vermont is a state of dense northern forest, of sugar maples and yellow birch and balsam fir, of ridgelines rising above 4,000 feet and river corridors cutting deep into the Northeast Kingdom. It is, in theory, exactly the kind of terrain that should keep large animals well away from the sidewalks and storefronts of even a small capital city. Vermont's moose population, currently estimated by state wildlife managers at approximately 2,000 animals, spread across more than 9,000 square miles of a state that is more than 3/4 forested, should have ample room. A 1,500-pound bull in prime rutting condition with tens of thousands of acres of northern hardwood forest available to him has, on the face of it, no reason to walk past someone's darkened dining room window at 2 in the morning. And yet, wildlife management agencies keep track of what they call nuisance wildlife incidents. It is a bureaucratic category for something that often defies bureaucracy, which is a 1,200-pound hoofed animal standing at the edge of a grocery store parking lot at midnight, exhaling clouds of breath in the cold air and surveying the scene with apparent calm. The Vermont Fish and Wildlife Department documented more moose-related urban and suburban incidents between 2018 and 2023 than during the comparable 5-year period before it. The pattern that emerged from those reports carried internal consistency. The incidents clustered in the same conditions: night hours, late winter and early spring timing, and specific landscape corridors leading out of forested land into populated areas. A yearling bull moved through the parking lot of a commercial building in Barre. A cow moose with a calf was photographed beside a garden shed in Stowe at 11 in the evening. A single adult male spent 3 consecutive nights traveling a stretch of residential road near Essex Junction before state wildlife wardens successfully redirected him toward the tree line. In Morrisville, a cow moose stood in a residential intersection for the better part of an hour while 2 patrol officers sat in their vehicles nearby with their lights off, waiting for her to move on. In all of these accounts, the detail that kept recurring in the warden reports and the wildlife officer narratives was behavioral. These animals were not panicked. They were not weakened. They were not performing the erratic, uncoordinated movements that typically signal illness or injury in a large ungulate. They were moving through human spaces with what every experienced observer described, in one phrasing or another, as calm purposefulness. One sighting is an anecdote. 7 is a pattern. What Vermont wildlife managers were looking at by the early 2020s was something between the two and beyond both. To understand what that means, you need to understand what a moose actually is, not in the casual way most people understand large animals, but in the specific, anatomical, ecological way that makes the behavior genuinely puzzling. Alces americana, the North American moose, is the largest member of the deer family alive on Earth. A mature bull in prime condition can stand 6 feet at the shoulder, carry antlers spanning 5.5 feet from tip to tip, and weigh up to 1,500 pounds. A cow moose, the type that shows up most frequently in these Vermont incidents, typically weighs between 700 and 1,100 pounds, stands 5.5 feet at the shoulder, and moves through terrain on legs that, on a large individual, can be nearly 5 feet long. Their hooves are broad and splayed, built for soft boreal ground and deep snow, and they are capable of delivering a kick with enough lateral force to crack a car door. In a given year, moose injure more people in North America than black bears do, because moose are not perceived as dangerous and bears are. Vermont's moose population has a specific and instructive history. The species was essentially absent from Vermont through much of the 19th and early 20th centuries, eliminated by hunting and habitat loss during the years when much of New England's forest had been cleared for agriculture. As that land reverted to young second-growth forest through the middle decades of the 20th century, moose recolonized Vermont from the north, moving south from Canadian populations and from neighboring New Hampshire and Maine. The population grew steadily, reaching an estimated peak of somewhere around 5,000 animals in the late 1990s. What happened after that is directly relevant to what is happening now. The primary driver of Vermont's declining moose population since that peak is a parasite called Dermacentor albopictus, the winter tick. Unlike other tick species that feed briefly and drop off, winter ticks attach in autumn and remain on a host moose for the entire winter, feeding continuously for months. A heavily infested moose can carry 90,000 or more winter ticks simultaneously. Research conducted by state wildlife biologist Cedric Alexander and published through the Vermont Fish and Wildlife Department found that tick-related mortality in Vermont moose calves has increased substantially as winters have shortened due to rising temperatures. When autumn snow arrives late, tick larvae have more time to climb vegetation and attach to passing moose before the cold arrives. When spring snowmelt comes early, the natural grooming behavior that would help a moose remove ticks is disrupted by the absence of snow to roll in. The moose that persist in Vermont today are, by any reasonable reading of the data, a population under ecological stress. But a stressed population does not automatically produce the behavior being documented. The geography of Vermont matters here in ways that maps don't fully capture. The Green Mountain Range runs down the center of the state like a spine, with ridgelines exceeding 4,000 feet in elevation, and a complex of river valleys draining east toward the Connecticut River and west toward Lake Champlain. Vermont's densest moose habitat sits in the Northeast Kingdom, the three-county region in the upper right corner of the state where the land is coldest, the forest is oldest, and the human population is thinnest. But the towns where moose incidents have been repeatedly documented don't fall inside that picture. Montpelier, Burlington, Stowe, Essex Junction, Barre, and Morrisville are connected communities, lit at night by streetlights and commercial signage, surrounded by residential neighborhoods where the nearest intact forest corridor might be a mile away through subdivision edges and drainage ditches. For a moose to reach any of them from traditional habitat, the animal would need to cross paved roads, move through subdivision margins, and navigate the narrow riparian strips and drainage corridors that thread between properties along river valleys. The Winooski River Corridor in particular has emerged, in wildlife camera documentation and warden observations, as a repeated pathway. The river runs from the mountains to Lake Champlain, passing through and between multiple developed communities. Animals moving along the vegetated river bottom are largely invisible to the residents above the bank. They surface only where the corridor intersects with roads, parking lots, and residential areas, which along the Winooski Valley happens regularly. This means moose can get to Vermont's towns. The question is not access. The question is motivation. If this channel is the kind of thing you come back to, the kind of video you watch because you want the actual explanation rather than the easy one, subscribe. Every week covers a case that hasn't been closed. Tell me in the comments where you're watching from. These animals are showing up closer to people than most people realize. Wildlife biologists have spent years distinguishing between what can be documented and what can be explained. Those are separate problems, and the space between them is where this question lives. What the documented evidence establishes is that moose in Vermont are capable of substantial movement across varied terrain. Radiotelemetry studies tracking collared moose in northern Vermont have recorded individual animals traveling more than 30 miles in a single season. Dispersing young bulls, pushed out of established home ranges by dominant males during the rut, have been documented crossing interstate highways, navigating suburban development edges, and reappearing in areas where moose had not been recorded in years. Moose are strong swimmers. They routinely cross rivers and small lakes. An animal that can cross the Connecticut River where it runs fast and wide has no particular difficulty with a 4-lane highway or a town common. Their sensory profile is built precisely for the low light, low visibility conditions found along forest town margins at night. Moose eyes are large, positioned laterally for wide peripheral vision, and adapted for low light detection. Their hearing is acute. Their ears capable of rotating independently to triangulate sounds at significant distance. They process information from their environment in ways calibrated for predator detection in dense forest, which means a quiet residential street at 2 in the morning, with its limited movement and minimal human presence, is, from a sensory standpoint, not a hostile or disorienting environment for an animal that evolved alongside wolves and bears in boreal forest. The sodium hypothesis has occupied wildlife biologists studying this behavior for decades. Moose have a documented need for dietary sodium that exceeds what most inland forest habitats can supply through forage alone. They seek it actively, through aquatic vegetation in summer ponds and wetlands, through mineral licks, and, increasingly, through road salt. Vermont applies somewhere in the range of 60,000 tons of road salt to its roads and highways each winter. The salt works into roadside soils and vegetation, creating concentrated sodium deposits along road edges that persist well into spring. A cow moose in late February, weakened by 4 months of cold, carrying a tick load that has been drawing iron and blood from her system since October, and growing a calf that is consuming her reserves from the inside, has a powerful physiological draw toward concentrated sodium wherever it can be found. The road salt explanation is documented. It is credible. It accounts for some of what is being observed. It does not account for all of it. Moose seeking road salt along highway shoulders do not typically make repeated visits to the same residential blocks over multiple consecutive nights. They do not stand in intersections and appear to surveil the surrounding houses. They are not described, consistently and independently by multiple experienced wildlife observers, as calm. Wildlife management has a long record of animals appearing in places where science said they had no reason to be, for reasons that only became clear after the fact. In 1938, a fisherman working off the coast of South Africa pulled up a living species of fish that paleontologists had declared extinct for 65 million years. The coelacanth was known only from fossils. When the living specimen appeared on a research vessel, the scientific consensus about its absence did not survive contact with the evidence. The fish was not new. The tools used to confirm its absence had been inadequate. In the American West, mountain lions were officially absent from the eastern United States for most of the 20th century. Individual mountain lions documented in Missouri, Illinois, and Connecticut were dismissed as escaped captive animals until genetic analysis showed they were wild-born individuals that had traveled more than 1,000 miles from established populations in the Black Hills of South Dakota. The agencies updated their range maps after the animals were already there. Closer to Vermont, the eastern coyote has no historical presence in New England. It arrived during the middle decades of the 20th century through an expansion out of Canada, crossbreeding with remnant wolf populations as it moved east and south, producing an animal genetically distinct from its western relative and significantly larger. Today, eastern coyotes are established across all of New England, present in suburban parks and city margins from Portland to Providence. They arrived before the science caught up with their presence. The precedents share a structure. An animal appears in an unexpected context. The explanation is deferred or rejected. Documentation accumulates. A new explanation eventually emerges that reframes the behavior as consistent with a process that was already underway, operating below the threshold of official recognition. The Vermont moose incidents may be early chapters of that kind of story. Honesty requires saying plainly what the skeptics have right. Moose are large animals. They are not subtle. Unlike a bobcat moving through a suburban backyard or a fisher cat crossing a parking lot at the edge of a tree line, a moose is nearly impossible to miss. If moose were routinely traveling through Vermont towns at night, the photographic record should be more extensive. The incident report should be more frequent. The skeptical position that these are random, isolated events being given a significance they don't deserve is a reasonable position. The answer to that skepticism has three parts, and not one of them requires the moose to be absent. The first is coverage. Vermont's developed areas are not under continuous observation. Security cameras point at front doors and driveways, not at streets. Trail cameras managed by state wildlife biologists exist deep in forested areas, not at the margins where forest meets town. A moose moving through a residential neighborhood at 2 a.m. in February is moving through a landscape where almost no one is awake, almost no equipment is running, and the narrow windows of surveillance that do exist point in directions that catch animals only by accident. The documented incidents represent what a sparse and intermittent monitoring system managed to capture. The second is classification. Moose incident reports in Vermont are filed as nuisance wildlife events, processed through Wildlife Division administrative channels, and stored without automatic cross-referencing against reports from adjacent counties or adjacent winters. Vermont Fish and Wildlife receives wildlife incident reports continuously. A moose in a bear parking lot is categorized, filed, and managed as a local event. It is not automatically placed beside a moose on a Montpelier street from 3 weeks earlier in a pattern analysis. The data exists. The aggregation of that data into something interpretable took researchers actively looking for it. The third part is timing. Moose are crepuscular and nocturnal. They are most active in the hours between 10 at night and 4 in the morning. The Vermont town incidents cluster precisely in those hours. These are the hours when witnesses are fewest, when security footage is least likely to be reviewed until the next morning, and when a 900-pound animal moving at a walking pace of 5 miles per hour can cover significant ground and be well back into forested cover before the first commuter starts their car. The absence of evidence is not evidence of absence. In this case, it describes the hours when most people were asleep. So where does that leave us? The Vermont moose incidents remain open. Wildlife biologists at the University of Vermont and within the state's Fish and Wildlife Department continue to collect movement data, monitor population health, and document the corridor use that appears to bring moose into contact with developed communities. The Northeast Moose Working Group, a multi-state research collaborative, is tracking population trends and behavioral data across New England. But the kind of analysis that would yield a definitive explanation for the nighttime town appearances, rather than simply confirming that they occur, requires multi-year telemetry data from individual animals across multiple winters. That work takes time. The winter tick crisis is reshaping Vermont's moose herd in ways still being understood. Climate change is altering the seasonal rhythms that govern tick survival, plant phenology, and moose body condition in ways that produce cascading behavioral effects. Habitat fragmentation is changing the landscape corridors available to dispersing animals. The convergence of those pressures may be producing something that doesn't yet have a name in the wildlife management literature. A behavioral shift in an animal whose relationship to the human landscape is changing in ways that happen to be visible. At 2 in the morning, to cameras pointed at driveways. Or it may be something more specific, a mineral need, an ecological pressure. A learned behavior passed between animals in a way that the science hasn't yet characterized. An explanation that will seem obvious in retrospect once the data is assembled. Go back to the beginning of this. A cow moose standing in a Montpellier intersection in February at 2:17 in the morning, 900 pounds of animal in the middle of an empty road, breath fogging in cold air, wide ears tracking the sound of a street lamp's electrical hum. She turned and looked at the dark houses along the road. She stood still for a long moment. Then she kept walking. The camera captured her leaving. It did not capture where she was going, or whether she had been there before, or whether she came back. Vermont Fish and Wildlife closed the incident report the following day and filed it appropriately. The question of why she was there in the first place is still open.